Hello everyone, I Dr. Odhesh Kumar, Assistant Professor, Department of Computer Science, MMB, Banaras Hindu University. I welcome you all in this course titled Digital Logic and Circuit Simulation. In today's lecture, we will discuss about what are the meaning of register and shift registers counters in. Here we talk about some special type of register generally used in digital electronics that are used for a data storage and used for a purpose of data movement. So, it is a primarily used for storage of digital data and do not process internal sequence of state as do counter. Generally counter process internal sequence of states, but here register are used as a storage device, not process or internal sequence of states. It has two basic functions, one is used for a data storage and another is for data movements, means data moves one bit left or one bit right at a time, and the data storage capacity of register is determined by the total number of bits of digital data it can retain. Suppose the total number of bits register retain is 4, then this means this register capacity is of 4 bit, that is 1010, means suppose the any binary information is stored in a group of 4 bit, that this means that is this register is known as a 4 bit register. Means the capacity of register determines how many number of bits stored in that register. Each stage, when we want to store a 4 bit or we want to make a 4 bit register, and we know that each flip flop is capable of storing a single bit. So, when we simply make a 4 bit register, then there is a need of 4 flip flops for storing that information, and generally we use a D register, D type flip flops when we make a register, whether it is a 2 bit register or it is a n bit register. Like as what happens here in case of D flip flop, this is a D flip flop and this is a clock pulse supplied, whatever the value of output based on this is a, suppose this is D. When input D is what? D is equal to 0, then what is the output? That is 0. Means what? When clock pulse is high and input D is 0, then whatever the present value, means when clock pulse arrives, then the output becomes 0. Or if the output is already 0, it is retained until the next clock pulse arrives. When D is equal to, suppose D is equal to 1, then what happens here? When D is equal to 1, then Q also 1, because we already know the features of D flip flop. This is nothing but a D flip flop. In a D flip flop, when clock pulse is high and whatever the value of input, same is supplied to the next, means it not depends on the previous stored value. Here each stage is in a register represents 1 bit, means each stage are the, when we want to simply design a 4 bit register that holds a 4 bit information, we simply use a 4D type of flip flop and the inputs are supplied to D and the same input is same information is retained by a flip flop. The shift register has a capability of register, some of the register that have a shift capability, some of the register that have a shift capability, and the shift capability of register permits the movement of data from stage to stage. Suppose there are 2 register, this means the data are transferred from whatever D is provided as input here, the same is, suppose this is a DB and this is a DA, whatever clock pulse of both are common, whatever the input provided here, that is CP, whatever the input provided, the same that has a shift capability, the same is stored here and the same is transferred here in DB, and this is the output that also retain the same. Group of flip flops which are used to shift data are known as shift flip. When some of the group of flip flops are used to shift a data from one location to another location in left direction or one location to another location in right direction, this is known as a shift register. Shift register of 2 types, left shift register and another one is a right shift register. Right shift register. Here register capable of shifting binary information either to the right, that is known as a right shift register, or to the left, that is known as left shift register. That means overall we can say that it is a shift register that is used either shifting the information left or right, depending on what it is known as a left shift register or right shift register. And shift register consists of chain of flip flop connected in cascade form, like as a chain of registers, chain of D flip flops, chain of flip flops connected in cascade. Suppose we want to design a 4-bit shift register, this means there is a 4 flip flops that are connected cascadely, means whatever the input of this, and this is what output, and this is input D, and same clock pulse is supplied to all the flip flop. Same clock pulse is supplied to all the flip flop. This is nothing but a D flip flop. Similarly, this is also a D flip flop. This is also a D flip flop. This is also a D flip flop. This means shift register consists of chain of flip flop. Here chain of flip flops are connected in cascade form with the output of one flip flop connected to the input of next flip flop. Here the output of this flip flop connected to the input of this flip flop, output of this flip flop connected to the input of this flip flop, output of this flip flop connected to the input of this flip flop, and finally output is produced by this flip flop. So, this is known as a shift register, and this is what? This is known as a right shift register, because the bit are shifted in right direction. When simply we make a left shift register here, this means this is one register, this is another, all are cascaded here, and this means the input are provided here from this D register, and then the output of this, the output, whatever the output of this, that is connected back to a input this. Similarly, output of this is connected, output of this, and finally the output, this is a what? Output. Means the output of each flip flop, the output of this is connected as a input of next flip flop, like here input D of next flip flop, this is input of flip flop, then the output is of this flip flop. Here this is what? Final output, this is output here, and this is the previous, this means this type of register, this is also D type flip flop. Here common D flip flop, D flip flop, D flip flop, D flip flop, and here in all register there is a common clock pulse applied. Here there is a common clock pulse applied here, common clock pulse, this is the common clock pulse applied here, and this is known as what? This is a clock pulse, this is simply CP. In this way, this is what? This is a, this rotate the information in a left direction, this means it is known as a left shift register, this is known as a right shift. Another is, suppose we simply design a serial in serial out register, simply this is what? Nothing but it is made up of, suppose we design a 4-bit serial in serial out register, then this is nothing but all the 4 flip flops are connected in cascaded form, and here whatever the input that is provided serially, here this is a input D, whatever the output, this is what? Q of this, suppose this is a, this is a B, this is a C, this is a D, all are a D flip flop, this is a D flip flop and input name is C, this is a D flip flop, input name is, this is a D flip flop and input name is what? B. Then simply what is the output? Simply this is the output state, this output state is also connected here in the cascaded form, then the from the next input, and then similarly the output of this is connected as input to the next, and the output of this is connected as in, and this is the finally output. This is a serial in, and all are have a common clock pulse is supplied to all, common clock pulse is supplied to all the flip flops. This is a what? This is a 4-bit serial in serial out register. Similarly, when we design a 4-bit serial in parallel out register, so this is what? Serial in, this is a serial in register, serial out, and parallel out is what? this is output, that is A is generated, this output B is generated parallelly, this is generated parallelly, C is generated parallelly, and this is also D is generated parallelly. This is a serial in 4-bit serial in parallel out register. What happens in case of parallel in parallel out register? Parallel out register, like as here 4 D flip flops are connected in the form of cascaded form, and in case of parallel output there is no need to connection of output of one flip flop to other. Here the input is provided parallelly like as a DA, here this is input is provided like as a DB, here input is provided like as a DC, and here input is provided like as a DD. And what will be the output? This is also generated parallelly. This is output is what? QD, this is QA, this is QC, this is what? QA. This is a complemented output, it is complemented output, this is complemented output, this is a complemented output, and here the clock pulse is common in all the flip flop. Clock pulse is common in all the flip flop, and that is given as a CP. This is a D flip flop, here D flip flop, this is also a D flip flop, there is also a D flip flop, there is also D flip flop. In case of this is 4-bit parallel in parallel out. This is what? This is 4-bit serial in parallel out, parallel out register. In this way we will design a different types of register. Now what here we discuss some special types of shift register that are generally used to produce a special sequence, and that register are known as a shift register counter, which is some of the shift register which are used as a counter purpose, counting purpose, and that is why these are known as a special counters, and these counters are named as a Johnson counter and ring counter. What is shift register counter? Generally it is a shift register, basically it is a shift register with the serial output connected back to the serial input to produce a special signal. Here this is an important point, it is a special type of shift register with serial output. The output is what? Output is serial with the serial output connected back to the serial input to produce a special sequence that is known as a shift register counter. There are two types of counter generally we study here, Johnson counter and ring counter. What is the meaning of Johnson counter and ring counter, and how we design the Johnson counter and ring counter? Let us see what is the meaning of Johnson counter. Generally the complemented, in case of Johnson counter we already discussed about what is the meaning of preset and clear in some previous classes in case of flip flops. In Johnson and Johnson counter and ring counter uses the concept of preset and clear here. In case of Johnson counter, the complemented output of the last flip flop is connected back to the input of a first flip flop. This is the important point. Only the ring means here, in case of suppose we simply design a 4 register here, 4 flip flops, D flip flops are connected as here. Now cascade connection, this means here suppose this is a whatever the value, suppose these are A, B, C, D, this is what? DA, this is what? DB, this is what? DC input, and this is the 4th input, or this is known as D1, D2, D3 and D4. What happens here? The output of this is connected to input of this. Similarly, the output of this is connected to input of this, output of this is connected to input of this, and this generates a final output. And whatever this generates, suppose this generates what? Q1, this generates what? Here this is Q1, Q1 complement, this is Q2, Q2 complement, this is Q3, Q3 complement, this is Q4, this is Q4 complement. Q4 complement. Here when we design this, what happens here, the complemented output of last, suppose this one is the first flip flop, then complemented output of the last flip flop is connected back to the input of first flip. This is the last flip flop, complemented output, then this is connected back to the first flip flop. This is connected back to the first flip flop, and here what happens, initially the clock pulse, we simply provide a common clock pulse to all because it is a, here we provide simply a common clock pulse to all the flip flops. All are a positive edge triggered flip flop. What happens here? Initially we clear all the flip flops, this means clear input is what? Clear input, this is clear input, and initially we supply a clear input, means all the flip flop whatever the value previously stored all are clear, because we know that when we supply a clear input to the flip flop, there is, it not depends on the input of the flip flop, means it directly determine the value of, when clear input is 0, this means all the output are clear, whatever is stored, all the output is stored simply all are zeros. Here the complemented output, suppose let us suppose initially all are 0 0 0 0, suppose this is a 4-bit Johnson register, what are the counting states, then what is supplied, then the next time when clock pulse becomes high, this is a, suppose this is a value of clock, when clock pulse, when first clock pulse arriving of first clock pulse, what is the, suppose initially that is clear, all are clear 0 0 0, then what happens here, this again goes to complemented form of Q4 is given here, this means this is 1, this means this is 1, and at that time already stored values are here, that is 0 0 0, means in clock 1. When next time, next clock pulse, what happens here, the complemented output is goes in this, and next values, this goes here, this goes here, this means what happens here, complemented, this means 1 1 0 0. Again what happens in the next time is here, that in clock pulse 2 what is stored here, that is 1 1 0 0. This means what is the complement of this, that is 1, because in case of D flip flop output is same as the value of D, here D is 0, this means it's what is the output 0, complement form is 1, this means there here 1 is goes, and then output of this is supplied to the next, whatever is stored here that is supplied here, what is stored here that is supplied in this case output of this, and what is stored here that is supplied here, this means this is again 1 1 0, sorry 1 1 1 0, this is third. Then what happens next, again here the 0, this means that is again goes here, that is this complemented form goes here, this means this is 1 1 1 1, this is fourth. Similarly again here complement, this is 1, then its complement goes 0 0 goes here, rest are same, rest this whatever the input output present here, that goes to input of this, this goes to input of this, this goes to input of this. This means here in the next clock cycle this is again 0 1 1 1, then in the next clock cycle 6 this is again goes here 1 complement, this means 0 0 1 1. In the next clock cycle 7th, this is goes here, that is 1 h goes, that is 0 0 0 1. In the next clock cycle 8, again this is 0 0 0 0, means again start the same counting sequence. So this is the case of 4-bit Johnson counter. How many number of state here, 0 to 7, and 8 is the same, that is already here. So this means total 8 states are counted by a 4-bit Johnson counter. This is what 4-bit Johnson counter. Generally what is special in Johnson counter, generally if the counter start at 0, this feedback arrangement produce a characteristic sequence of state, and Johnson, suppose here the counter start from 0, and Johnson counter will produce a modulus of 2n. Modulus of 2n means total it counts a 2n states, where n is the number of bits in a Johnson counter, then it simply Because for designing a 4-bit counter there is need of 4 flip flops, and it counts how many number of sequence? It counts total 2 multiplied by n. That means in case of this there is a 4-bit counter used, this means 2 multiplied by 4, that is 8 sequence are count, and if the initial sequence is 0 0, then it count up to 0 0 1. 1 0 0 means special sequence are count 1 0 0 0 0 0, then 1 0 0, next in the next sequence is what, next state is what, this, the next state is this, the next state is this, then next is this, next is this, next is this, next is the, and then again go back to 0, and in the same way it counts again and again. This is a 4-bit counter. Similarly, for designing a 5-bit Johnson counter, how many number of states are there? When in case of 5-bit counter, the number of states there are 10 states. Why? Because it is multiplied by, there are 2n states are there in case of n-bit counter. That particular, as per this formula, the total number of 10 states are there. Similarly, for designing a 5-bit Johnson's counter, 1 flip flop is added here, and the complement of 5th flip flop is go back to here. Next is the ring counter. Generally, the ring counter utilizes 1 flip flop for each state in a sequence. 1 flip flop for each state in a sequence. Suppose we want to design a 4-bit ring counter. We want to design 4-bit ring counter. This is what, nothing but a D flip flop, D flip flop, D flip flop, D flip flop. Suppose this is D1, D2, D3 and D4, and this is what, common clock pulse is goes to all. This is a clock pulse. Another is what are the clear input. Generally here this is clear input is provided to all the flip flop excluding the least significant flip flop. This is a clear input. Clear input means whatever is stored previously in that the output becomes 0, and there is a preset. In this case there is a preset input. In case of first flip flop there is a preset input is there. This is a preset input. Preset input means when preset input is 0, what will be the output? The output is 1, and when clear input is when preset input is 0, then what will be the output of Q? The output of Q becomes 1. This means suppose initially the preset and then D flip flop of this is connected, this is connected to the output of this is connected to the next input of next flip flop, output of this is connected to the input of next flip flop, and here this is what? This is a complemented output, like as here this is Q4 complement, this is Q3, this is Q3 complement, this is what? This is Q2, this is Q2 complement, and this is what? Q1, this is what? Q1 complement. Here what happens in case of Johnson counter, we simply connect Q4 complement in the form of feedback, and there is no need of preset input, but here in case of this Q4 means the output of last flip flop is connected in the form of feedback to input of first flip flop, and in this way it forms a ring. That is why it is named as a ring counter. It is a special counter that counts some special sequence. And what sequence it counts? Suppose here when the preset, we know that what happens when the preset is 1. When the preset is 1, the corresponding output value of flip flop becomes 1. So, initially all the flip flops here, the ring counter utilizes 1 flip flop for each state in its sequence. Suppose we want to count a 10 state, then 10 counters are 10 flip flops are required. Suppose we want to count a 4 sequence, then 4 flip flop are required. And what are the value of that counting sequence? We will discuss here. Clear signal is firstly applied to all the flip flop except first flip flop in order to reset the output to logic 0. Means we applied a clear input to all the flip flop for reset the value of those particular flip flops, and then preset is applied to only first flip flop before the clock pulse are applied. Before the clock pulse are applied. So, when preset is applied, then simply the output first becomes 1. So, this is what 1 0 0 0. When preset is applied to this flip flop and then apply a clock pulse, so then when preset is applied, this becomes output of this becomes 1, and rest are cleared by this input, this means that are 0 0. What is the next? Here the Q0 is again connected back to D1. What is the value of Q4 here? This is suppose Q1, Q2, Q3, Q4. What is the value of Q4? Q4, that means again connected back, this means 0, 1, 0, 0. Then again Q4 connected back, this is 0, 0, 1, 0. Again Q4 is connected back, this is 0, 0, 0, 1. And again this connected back, what happens here? That 1, 0, 0, 0. Then same sequence occurs here. This means it counts in clock pulse 0, 1, 2, 3. What happens? This means total it counts 4 sequence. This means the number of state counted by a ring counter that is equal to the number of bits in that ring counters or the number of flip flops. If there are 4 flip flops in a ring counter, it counts only a 4 state. If there are 10 bits in a ring counter, it counts a total 10 states. If there are 15 counters, 15 bit ring counter, this means there are 15 flip flops. D flip flops are connected in this way. Here all are a D flip flop, D flip flop, this is also a D flip flop because, and this is also a D flip flop. So in this way, this is all over about a ring counter and how we design a ring counter, what is the meaning of ring counter, how ring counter is differ from a Johnson counter, what is the meaning of Johnson counter, how many states special sequence are counted by a Johnson counter, how we simply find the values of these state, what are the meaning of preset and clear input. In case of Johnson counter, which of the flip flops are connected by using a clear state, all the flip flops are connected by a clear state. In case of ring counter, only excluding a first flip flop, rest flip flops are connected through a clear input and first flip flop is connected through a preset input, not this is written as preset input here, preset. So this means this is all over about what is the meaning of register, what are the different types of register, what are the some special type of shift register counters in which we discussed about ring counter and Johnson counter. Thank you very much.